I'm John Anrucain Haveliana, and in this video, we will solve a problem on single unit material balance. This is under Day 2, Chemical Engineering Principles of the Chemical Engineering Board exam, specifically under A1, Material Balance. So for our problem, we're given air is bubbled through a column of liquid hexane, C6H14, at a rate of 0.1 kilomoles per minute. The gas stream leaving the drum of the column contains 10 mole percent hexane vapor. Consider air as insoluble in liquid hexane. Assume that air neither dissolves nor reacts with hexane in the process unit. The specific gravity of liquid hexane is 0.659. Question number 1. Calculate the amount in kilomoles per minute of gas leaving the drum of the column. Number 2. Using the integral mass balance, determine the total process time in hours to vaporize 10 cubic meters of liquid hexane. And number 3. Solve for the accumulation term in kilomoles after vaporizing 10 cubic meters of liquid hexane. For the first question, calculate the amount in kilomoles per minute of the gas leaving the column. And we are given the choices 0.121, 0.111, 0.101, and 0.12. To solve this problem, let's consider this block flow diagram of the bubbling process. Let's consider this as the drum of the column where air is delivered into the unit. Let's denote that as N.air equal to 0.1 kilomoles per minute. The exiting stream is composed of N.air, N.air still equal to 0.1 kilomoles per minute because we assume that air is insoluble and doesn't react with hexane. At the same time, we also have hexane C6H14 leaving the unit. The important information for the first question is that the gas stream leaving the drum of the column contains 10 mole percent of the hexane vapor. So we can represent that as the moles of hexane divided by the total moles leaving the unit or the exiting stream is equal to 10 mole percent. In the form of equation, we can write that as N dot C6H14 divided by N dot C6H14 plus N dot air equal to 0.1 or 0.10. This is the 10 mole percent hexane vapor. So 0.1 is equal to N dot C6H14 over N dot C6H14 plus N dot air, which is 0.1 kilomoles per minute. So this equation has only a single unknown, which is N dot hexane. Using our calculator, we can compute for N dot C6H14 as equal to 1 over 90 kilomoles per minute. Or in decimal form, this is 0.011 kilomoles per minute. The question is the amount of gas leaving the column. So we need to still add the molar flow rate of air, which is 0.1 kilomoles per minute. So adding the two values, 0.011 plus 0.1, the total flow rate is around 0.111 kilomoles per minute. From the choices, this is letter B. Question number 2. Using the integral mass balance, determine the total process time in hours to vaporize 10 cubic meters of liquid hexane. The next information that we need is the specific gravity of liquid hexane, 0.659, and its molar mass. So our computational path becomes volume vaporized in terms of liquid hexane, and then we will relate that the mass of liquid hexane and then relate that to the moles of liquid hexane that is vaporized. Okay? For the first information, we need to calculate or determine the molecular weight of hexane. We can calculate or find the molecular weight from Perry's Chemical Engineering Handbook. Or we can solve. We have 6 carbon atoms. So 6 times 12.01 grams per mole plus 14 hydrogen atoms, 1.01 grams per mole. Solving, the molecular weight of hexane is equal to 86.20 grams per mole. Or this is similar to 86.20 kilograms per kilomole. Next, the specific gravity of liquid hexane, Sg, is equal to 0.659. And this can be translated to a density of 659 kilograms per cubic meter, using water as our reference fluid. Take note that the vapor hexane that leaves the unit is equal to the amount of liquid hexane that is lost in the drum. Now that we have the molar mass of hexane and its liquid density, we can now calculate the total process time. We can start with 10 cubic meters. So this volume of liquid hexane, we first convert it to the mass of liquid hexane. So we multiply density, 659 kilograms per meter cube. Next, since we now have the mass of liquid hexane, we can now calculate the moles of liquid hexane that vaporize. So we divide the molar mass, 86.20 kilograms per kilomole. And then lastly, we have previously calculated the molar flow rate of hexane that leaves the unit. So we can divide the molar flow rate, 1/90 kilomoles per minute. And the last step is to convert minutes into hours. Hours over 60 minutes. So cancel meter cube, cancel kilograms, cancel kilomoles, cancel minutes. So we can now calculate the total process time. And this is equal to around 114.67. So from the choices, it is letter B. We will still use this value in the next problem so we can store this to our calculator. And lastly, for question number 3, find the accumulation term in kilomoles after vaporizing 10 cubic meters of liquid hexane. So since the unit loses hexane, it will be in terms of negative accumulation, or alternative term is depletion. So from the previous value, we have determined that the process time is 114.675 hours. Let's convert that again to minutes. 60 minutes or, and then multiply the molar flow rate of hexane that leaves the unit. Let us use negative as a sign for loss of mass from the unit. Negative 1/90 kilomoles per minute. We'll cancel hours, cancel minutes, and we'll have kilomoles as our unit. Calculating, our value is negative 76.45 kilomoles. From the choices, this is letter B. And that's it for our question on material balance. If you enjoyed this video, please like and subscribe. See you in our next video.